Hey everyone, welcome back to AP Precalc. This is lesson 3.3. Let's get right into it. All right, so here's the bell ringer for today. Pause the video if you haven't done this yet because I'm about to go over the answers. So for these, we want to convert the following angle measures to the other type. So the first two are going to be radians because we see a pi in it. And so we're going to convert those to degrees. And then the next two, we're going to convert from degrees to radians. So here for the first one, pi over 6, this is going to be, if we multiply this by 180 over pi, the pi's cancel out. 180 divided by 8 should be 30, so 30 degrees would be that one. And then the next one, 3 pi over 4, if we multiply that by the same factor, 180 over pi, which is basically just multiplying it by 1, 4 times 180, this should be 45. So 3 times 45 is 135, and then the pi's will also cancel out. So that should be our first two. 300 is going to be times pi over 180. And so 300 over 180 should be 5 over 3. And then the pi is still going to be there. So 5 pi over 3 should be our answer for that third one. And then 150 times pi over 180. 150 over 180 should be, as a fraction, 5 over 6. So this should be 5 pi over 6. So that should be our answer to our bell ringers there. And now what we're going to get at today is looking at the coordinates of a point of a circle that's centered on the origin that may not necessarily be a unit circle. So we looked at this with a unit circle before where the radius was always 1. But what happens when the radius is maybe like 4 or 5 or 10? So given an angle theta in standard position with a radius of r, there is a point P that the terminal ray, this ray right here, will intersect the circle at point P. The location for that point P is going to be r cosine theta and r sine theta as coordinates. Now, how do we know that? From 3.2, we remember that we had cosine theta equals x over r as a ratio. So let me write it here. Cosine theta equals x over r. Now let's just solve for x. So if we multiply both sides by r, you would get r cosine theta equals just x, because the r's will cancel out on the right-hand side. This means our x coordinate is going to be our radius length times the cosine of that angle measure. Same thing with sine. If you had sine theta equals y over r, multiplying both sides by r, you get r sine theta equals y. And that's our y coordinate, our radius times our sine length. This is really what a unit circle is, but when the radius is 1, it just simplifies to cosine comma sine. When the radius isn't 1, we basically just take our coordinate and multiply it by our radius. And so this is going to be our coordinate for any point on a circle like this. So let's take a look at example 1. The figure shows a circle of radius 4 along with an equilateral triangle. So here we know our radius is 4. P, Q, O, which of the following gives the coordinates of point Q? So remember, if we take a look here, this is Q, and then an equilateral triangle is a triangle where every angle is 60 degrees. So if we take a look, this should be 60 degrees, and then this should also be 60 degrees. So in total, this full angle theta should be 120 degrees. What's 120 degrees, though, in radians? Here, if we multiplied it by pi over 180, you would get 2 pi over 3. So that's going to be our theta measure in radians. So let me label that now on the graph. So here, theta, where theta is equal to 2 pi over 3. And so our coordinates of Q are going to be r cosine theta, comma r sine theta. And so what is our r going to be? Our r is going to be cosine, or r is going to be 4 in this case, and then cosine 2 pi over 3, comma 4 sine 2 pi over 3. And that should be our answer there. C was the one that matches up to that, so C is the correct answer. Now, I know what you may be thinking, right? If you actually look at this as xy coordinates, you're like, wait, but x should be negative. Y is for cosine 2 pi over 3 not negative? And the answer is it actually is negative because cosine of 2 pi over 3, this value here, will be a negative number. It just may not look negative from the outside unless you actually evaluate it as an actual number. So that is why 1 is C there. All right, so sine, cosine, and tangent on the unit circle when the radius is 1. So going back to that simplified unit circle, it turns from r cosine theta, r sine theta, to just cosine theta, sine theta, because your radius is 1, and that really doesn't impact anything. So just know the x-coordinate of any point on the unit circle is the cosine value for that angle, and same with the y-coordinate and the sine value for that angle. So let's take a look here. Consider the unit circle with P, Q, R, and S labeled above. Find the values of the following. So here at 0 degrees, that's going to look or just match up with point P. The coordinate of P is 1, 0, which means cosine of 0 should be 1 and sine of 0 should be 0. So with that, we can fill in our first two there. And it's literally just going to be our x and our y coordinate at all of those angles. So pi over 2 is 90 degrees, and so cosine of pi over 2 is our x coordinate there, which is 0. Sine of pi over 2 is our y coordinate, which is 1. For E and F, cosine of pi, -1, sine of pi, 0 as well. And then for G, should be 0 there, and then -1 for H. All right? So those are really 4 easy coordinates to know when it's 0 and 1 and -1, but they will get a little bit harder. So now finding reference angles is something that is really important. And so a reference angle is always going to be the acute angle between the terminal ray, so basically that line or that ray that forms the angle, whether it's there or here, and then the x-axis. So this will always be a part of a reference angle. Not the y-axis, but the x-axis. Here, it's just going to be the smallest angle made with the terminal side and the x-axis, and it's always going to be an acute angle except when it's exactly 90 degrees. So let's say we just have a ray like this. Our reference angle is going to be this angle right here, and we're going to use reference angles to help us because in today's lesson, we will memorize the entire unit circle, or we'll know what sine or cosine is for every single angle measure in increments of 30 and 45 degrees, and this will help us. So let's take a look at example 3. Find the reference angles for the following angle measurements. So we can give these in terms of degrees for this one. That's okay. So this would be 30 degrees, 45 degrees for this one, and then 60 degrees. So those are pretty easy. For 120 degrees, though, our reference angle is going to be this, which is also 60 degrees. 135 should be 45 degrees. And then 150 should be a 30-degree reference angle. 210, even though it's below the x-axis, it's still a positive reference angle. So 30, 45, and then 60 degrees there. Same thing with 300. This would be a 60-degree reference angle. 45-degree reference angle, and then 330 would be a 30-degree reference angle there. Now, finding sine and cosine function values. This is what you're going to memorize before the end of class. It may look daunting, but it's not as bad as it may seem. The unit circle is basically when the radius is 1, every single value for sine and cosine, like I said, with multiples of 30 and 45 degree angle measurements between 0 and 360 degrees. So you won't have to memorize like sine of 720 degrees. So we already know any value of 0, 90, 180, 270, and 360, any 90-degree increments, just by looking at the coordinates of a circle when the radius is 1. So we don't need to memorize that. We'll just need to memorize the rest. And then, honestly, we really need to memorize just the first quadrant. Once we have this, we can use reference angles, as I'll show you later, to find the values of the other three. But if you just know the first quadrants sine and cosine values, you are all good to go for this lesson. So to memorize the first quadrant of the unit circle, there's 3 different methods that I have because I know not everyone learns in the same way. During this video, I will go over all 3 methods. However, during class, I'm only going to go over way number 1. You really only need to know one of these methods. You don't need to know all 3 because you're learning the same thing essentially. If you have questions though, please feel free to come to office hours and ask me questions about any one of the 3 ways, and I will be happy to go over them with you in office hours. So let's start with way 1. This is going to be the table method, and so you're going to start by making a 3x6 table like this, with all the angles from 0 to 90 degrees. So in the first quadrant, remember this is going to be 0, 45 directly in the middle, 90, and then if we cut this into thirds, you have 30 and 60 degrees as well. And then we just want the sine and cosine values, so you're really not worried about tangent here. So let's work through this step by step. So step number 2 is simply just writing the numbers 0 through 4 in the sine row, increasing by 1 and going from left to right. And so just remember, like 0 kind of matches up with 0, and then you're going all the way to 4. Make sure that you have that sine row on top because you want this to be in the sine row, not the cosine row. Step number 3 is in your head or on paper, take the square root of each number and simplify when necessary. So here you had 0, 1, 2, 3, and 4. So the square root of these is the square root of 0 is just 0. The square root of 1 is 1. 2 and 3 are going to be kind of left as is. And then the square root of 4 is 2. And now the final thing is once you have your numbers here, so this was our numbers from the last row, take every number and divide it by 2, and then simplify when you can. So here, 0 over 2 is just 0. 1 over 2 is going to be left as 1/2. This will be left as root 2 over 2. This is root 3 over 2. And then 2 over 2 is just 1. So those are going to be your sine values from 0 to 90 degrees. And then remember from geometry, if we have a right triangle and we have theta here, sine of theta is going to be opposite over hypotenuse. Now let's say we have angle x here. Cosine of x is going to be equal to, so this was opposite, hypotenuse, and adjacent. Cosine is actually going to be the adjacent side, which is still like O in this case, over hypotenuse. So sine of one angle, and then if you take cosine of the supplement or complement of it, right, when these 2 angles have to add up to 90 degrees, they're going to be equal to each other. So sine of 0 should be cosine of 90, sine of 30 degrees should be cosine of 60, and so basically just flip them. So swap this one, move it there, take 1/2, move it there. This will also be the same because 45 is 45. 60 will go there, and then 1 will go here. So let me erase this so you can get all that copied down there. And that should be our sine and cosine table. Once we have this, we can then fill in any unit circle with this table. So let's try example 4 and example 5. First, let's fill in the table between sine and cosine from 0 to 90. I will actually give you this table on your quiz for you to work with. Obviously, on the AP exam, they're not going to give you a blank table to fill out. You will have to create this from scratch, but obviously this is not a hard table to do. So once we have this, let's work through and do what we just did with example 4. So we have 0, 1, 2, 3, and 4, and then we take the square root and divide it by 2. This would simplify to 0. This simplifies to 1/2. That can't be simplified, so that's good there. This also cannot be simplified, so 60 degrees is good. And then 90 is 2 over 2, which is 1. Now let's flip it. So this going from kind of right to left here. 1, root 3 over 2, root 2 over 2. So 45 will stay the same. 1/2 here, and then 0. So that should be how you would get your sine and cosine values for the first quadrant there. That would be our table. And then find the values of the following expressions. Sine of pi over 3. Pi over 3 is 60 degrees, so this is just equal to root 3 over 2. Cosine of 0 is 1. And then sine of pi over 4, that's 45 degrees, and so this would be positive root 2 over 2. So that would be our 3 answers for example number 5. Example number 6, fill in the first quadrant with the coordinates of each point. So here, this would be obviously 1, 0, and then this would be 0, 1. Those we can fill in pretty quickly, and then we would use our table, so you should still have it in your notes here. Cosine will be root 3 over 2, and then sine of 30 degrees is 1/2. This is easy. For 45, they're both just going to be positive root 2 over 2. And then this one is going to be our 30-degree coordinate, but flipped. So 1/2, comma, root 3 over 2. So it's going to be kind of swapped with each other there. So that's example 6. And now let's move on to the other 2 ways. Honestly, you can skip forward past way 2 and 3 if you are just trying to complete the lesson and way 1 makes sense for you. This is going to be the 5-finger method. And so what this is you want to spread your left hand, kind of lay in front of your notes right now or in front of your iPad or laptop screen, and look and try to see that your thumb and your pinky can make a right angle. The first quadrant is the top right side of the circle. So this is going to act as your first quadrant, with this being your y-axis and this being your x-axis, your thumb and your pinky respectively. Right? If we take this, your thumb will represent a 0-degree angle, and then every finger will represent another major angle. So 30, 45, 60, and then 90 degrees there. Once you have your 5 angles, to find the cosine value of an angle, put down the finger that you want to represent to find the cosine value. So let's do this with a 30-degree angle. With a 30-degree angle, you're going to be putting down your index finger, and so that means you're going to have 1, 2, 3. This one's going to be kind of put down, and then your thumb is still there. To the left of that finger, you're going to count how many fingers you have to the left, which is, in this case, 3. So here we're trying to figure out cosine of 30 degrees. This is going to be 3. And then take the square root of that number and divide it by 2 to get root 3 over 2. That one can't really be simplified. And so that is cosine of 30 degrees. Now, what happens if we want to find sine of 30 degrees? That's going to be, you take the number of fingers to your right after you have that finger down. So that would just be your thumb here. So this would be 1, and then take the square root divided by 2 to get 1/2 as sine of 30 degrees. So this is basically just the same thing that we did with the table, but you can just do it for a specific value if you want. So remember, cosine is to the left. The number of fingers for sine is going to be to your right. And then once you have that number, you're just going to take the square root and divide it by 2. Let's take a look at what happens if you were doing, let's say, cosine for a 0-degree angle. So cosine of 0. If you couldn't just look at the xy coordinate and look at those points there, put down your thumb and then you count 4 fingers to the left, and then you take the square root and divide it by 2 to get 1, and that would be cosine of 0 is just the value of 1 there. All right, way number 3 is first principles, and so with this one, you're going to need to know 30, 60, 90 triangles and 45, 45, 90 triangles as well as SOHCAHTOA. So taking a look, we want to use these 2 triangles to find sine, cosine of 30, 45, and 60 degrees. We already know 0 and 90 from the unit circle and just the coordinates there if the radius is 1. So let's take a look here. If we have a 30-degree angle, then this would be a right angle. And remember, for a 30-degree angle, the sides are going to be x root 3, and then 2x in this case. And now, simplifying this, we want sine of 30 degrees. So sine of 30 degrees is going to be opposite over hypotenuse. So x over 2x, which will simplify to 1/2. So sine of 30 degrees is going to be 1/2 there. Sine of 45 degrees. This one we're going to need a 45, 45, 90 triangle, which remember the sides are x, x, and then x root 2. Here, sine is opposite over hypotenuse, which is x root 2. And then here, you would technically get 1 over root 2, but we would want to rationalize the denominator to get root 2 over positive 2, and that should be our 45-degree angle there. If we did a 60-degree angle, let me erase the 30-degree angle one and draw a 60-degree angle for theta. So here, this is going to look a little something like this, where it's 60 degrees. This would then be 30 degrees, so it would be x, x root 3, and then 2x there. Taking a look for 60, for sine, it's opposite, x root 3 over hypotenuse, which is 2x. This then turns into root 3 over 2. And then once you have your values for sine, you can simply just flip them around to get root 3 over 2, root 2 over 2, and then 1/2 for the cosine values as well there. Or you can take a look at the triangles too and do adjacent over hypotenuse for each one. So now that we have the sine and cosine values for quadrant 1, we can fill in the following points, right? We know 1, 0, we know 0, 1, and then we know our 3 values for 30, 45, and 60 degrees. And so that's what we really want to know, because once we have all this memorized, we can then use reference angles to fill in the rest. So that's what we're going to use. And so all you need to do is any angle with the same reference angle will have the same value of sine or cosine. It just could be positive or negative depending on what quadrant it's in. So for example, let's take a look at 150 degrees, and let's say I ask you for cosine of 150 degrees. That's going to be right here, right? This may be 150 degrees, but the reference angle is going to be 30 degrees, a 30-degree reference angle. So then cosine of 150 is going to be equal to cosine of 30 degrees, which from our table is root 3 over 2. However, you need to remember if it's positive or negative. So let's take a look at our mnemonic device, right? All students take calculus. Here in the second quadrant, only sine is positive, so this should actually be a negative value. So negative root 3 over 2 should be cosine of 150 degrees, and that would be our answer there. So as long as you know reference angles, you know the first quadrant, and you know what quadrants sine and cosine and tangent are positive in, you should be good for all of these values there. So it may look daunting, but it really is not that bad. So example number 7, fill in the blank unit circle with coordinates and radian measures for the missing angles. So let's do that now. And so first off, let's do the radian measures. So this should be pi over 3. This is 2 pi over 3. This would be 3 pi over 3. This one is going to be 4 pi over 3, 5 pi over 3 here, and then 6 pi over 3. Now let's do the pi over 4s. So pi over 4, 2 pi over 4. This is 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, and then 7 pi over 4. And then 8 pi over 4 is 2 pi. And now let's do the pi over 6s. So pi over 6, 2, 3, 4. This is 5 pi over 6, 6, 7 pi over 6, 8 pi over 6, 9, 10, and then this is 11 pi over 6. So those are our radian measures there. Now we need to fill in our unit circle. So we know every increment of 90 degrees, that's already filled out. Let's fill in the rest. So what I'm actually going to do is I'm going to write the coordinates of that we see in the first quadrant, just with a little bit of space where we can make it negative if we need to. So for like 2 pi over 3, That's going to be the same as our 60-degree reference angle here. So all of the ones with a red circle around, I'm going to write 1/2 and then root 3 over 2. Let's do that. There. That should be good. Now, any angle with a blue circle around it, so those 45-degree reference angles, I'm going to write just root 2 over 2 for both sine and cosine. Then finally, for anyone with a 30-degree reference angle, so those 4 there, I'm going to write root 3 over 2 and 1/2 for those respectively. Right? Once we have that, though, the job's not done. So now we need to add positive or negatives. So we basically have to look and see what quadrant is each trig function positive or negative in. So for example, sine is, so in quadrant 1, every single angle is positive no matter what. So no negative signs needed in quadrant 1. Remember, this is also cosine comma sine. In quadrant 2, only sine is positive, which means we're going to have a negative and then a positive value. So I'm going to add a negative sign in front of every x coordinate. And then every y coordinate, right, because they're all above the x-axis, they all should be positive. So I'm just going to leave them positive right now. For tangent, that means cosine and sine are both negative. So I'm going to add a negative sign in front of both values, which is why I left a little bit of space when I was writing out my coordinates. And then for cosine in the fourth quadrant, that means cosine will be positive, but sine should be negative. So I'm going to add a negative sign in there. And those are going to be the complete unit circle filled out just like that. So if you know your first quadrant, right, it's pretty easy to distribute that to the other 3 quadrants. And then just remembering the mnemonic device, all students take calculus, you can fill in and add those negative signs as needed there. All right, so that's what it should look like. I will expect you to fill this out on your next quiz. It is important to know that I will give you a blank one. I'll also give you at the bottom of this like a blank table where you will fill it in. And then I will ask you for 15 values from this. So I may say, what is cosine of 5 pi over 4? And then you will have to find this and tell me it's negative root 2 over 2 there. So you'll have 15 of those as well that you will need to do too. All right, so let's work through example 8 together. Find the values of the following expressions. And so with these 12, let's work through them I'm going to start by drawing out the first quadrant of the unit circle just in the top left corner. So here, and then drawing our 3 angles. So this should be, let's see, 1, 0, and then 0, 1, and then just reminder it's cosine, sine. This then should be root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and then this one should be 1/2, root 3 over 2. And so once we have this, I'm going to then take a look at each angle. So here we have sine 2 pi over 3. For me, that looks like this. I know that. And that's going to be a 60-degree reference angle. And it is in the second quadrant where I'm also going to leave this up. All students take calculus. So it should be the sine value, but positive. So this should be root 3 over 2. And that should be our answer for A. Cosine 5 pi over 4 is going to be right here, 45-degree reference angle. It's going to be root 2 over 2, but then it's in the third quadrant where only tangent is positive, so it should be negative root 2 over 2. Cosine 11 pi over 6. This is going to be a 30-degree reference angle. It's going to be the cosine value, but cosine is positive though, so we're just going to keep it positive, so it should just be positive root 3 over 2 there. Sine 7 pi over 4, that's going to be this quadrant right here, so the fourth one. Only cosine is positive, which means this value should be negative. And because it's a 45-degree reference angle, it's going to be a root 2 over 2. 4 pi over 3, this is going to be 60-degree reference angle in the third quadrant, so it's got to be negative. And then the cosine value for a 60-degree reference angle is going to be 1/2. So this should just be negative 1/2 as our answer there. Taking a look at number 7, 7 pi over 6, that's going to be right here, 30-degree reference angle, and that is going to be sine of 30 degrees is 1/2, but then it's in the third quadrant, so it has to be negative, so negative 1/2 there. Cosine of pi, this is just, if you take a look at pi, the coordinates there are -1, 0. Cosine's the first coordinate, so -1. Sine 3 pi over 2, this is the coordinate there. This should be 0, -1. Sine is the second coordinate, so that would also be -1. Cosine 2 pi over 3, this is going to be right here, 60-degree reference angle. Cosine of 60 degrees is 1/2, but unfortunately cosine is negative in the second quadrant, so that should be -1/2. Cosine 5 pi over 3, that's going to be a 60-degree reference angle in the fourth quadrant. It's got to be positive. And then cosine 5 pi over 3 is going to be just 1/2 there. Sine of 0 is 0. And then cosine pi over 2 is also just 0 as well. So that should be those 12 there. If you have any questions, please come see me in office hours, and I will see you guys later. Thanks.